Hi, now here we've got an example on matrices, and transformation matrices and finding inverses. So if you'd like to give this a go, if you haven't done so already, do pause the video, come back as usual and check your work solution against mine. Okay, so welcome back if you had a go. So in the first part we're told that this matrix X is equal to 1, 3, A2, where A is a constant, and we've got to find the value of A for which the matrix X is singular. Now for singular matrices we should be familiar with the fact that the determinant of that matrix, in this case X, must equal 0. And so therefore, if that's the case, working out the determinant, we do the product of the two elements in the leading diagonal, so that would be 1 multiplied by 2, and then we subtract the product of the two elements in the trailing diagonal, so that would be 3 times A. So that's our determinant, and it's got to equal 0. So essentially we've got 3A equals 2, rearrange that, and you end up with A equals 2/3. Now in the next part we're given that y equals 1, 3 minus 1, 2, and we've got to find the inverse matrix for y. And to find the inverse matrix for y, first of all we've got to find the determinant of that matrix. So the determinant then for y is going to be equal to the product of the leading diagonal, 1 times 2, which is 2, and from that we subtract the product of the trailing diagonal elements, so that's 3 times minus 1, which is minus 3. So 2 minus minus 3 is 5. That's our determinant. And that means that from here we can find the inverse matrix for y, because it is always 1 divided by the determinant, 5 in this case, and then what we do is we switch the two elements on the leading diagonal, so that's 2 and a 1, and we change the sign on the two elements in the trailing diagonal, so that's going to be minus 3 and that's going to be 1, and there we go, there's our inverse matrix for y. Now in this last part we're told that the transformation represented by y maps the point A onto the point B. And we're given that B has these coordinates, 1 minus lambda, 7 lambda minus 2, where lambda is a constant. And we've got to find, in terms of lambda, the coordinates of the point A. So essentially what we've got is this point, say A, and we apply the matrix y to it. So if we were to do y multiplied by A, it takes us to this new point B. And that's essentially how we build this part up. So with this we're saying that y multiplied by the point A, which we're going to give as a vector, okay, we'll just do a little squiggle underneath that, gives us the point B expressed as a vector. Now to get A, we've got to remove the y. And the way we do this in matrices is to pre-multiply both sides by the inverse of y. So we've got the inverse of y multiplied by A equals the inverse of y multiplied by B. Now the inverse of a matrix multiplied by the matrix gives us the identity matrix. And the identity multiplied by A just leaves us with A. And then on the other side we've just got the inverse of y then multiplied by B. So we just got to apply that matrix multiplication now to get A. So if we just put therefore A equals, okay, the inverse of y, we've got it up here in part B, 1/5 then of the matrix 2 minus 3, 1, 1. And we multiply that by the vector representing the point B. So that's going to be a column vector, 1 minus lambda and 7 lambda minus 2. So when we expand this, let's just leave the fifth out the front. Okay, what we're going to have then is 2 multiplied by 1 minus lambda and then plus 1 times 7 lambda minus 2, row by column. So 2 times 1 minus lambda is going to give us 2 minus 2 lambda, and we add to this 1 times 7 lambda minus 2, so that's going to be just 7 lambda minus 2. Now we do the bottom row here multiplied by the column, so it's minus 3 times 1 minus lambda, giving us minus 3 plus 3 lambda, and then to this we add 1 times 7 lambda minus 2, so that's going to be 7 lambda minus 2. So if we now just simplify this, what we therefore have is that A equals 1/5 of, and grouping the terms up in the first row gives us 5 lambda, and grouping up the terms in the bottom row here gives us 10 lambda minus 5. So if we take a fifth of these values, we're just going to have lambda and 2 lambda minus 1. So this is the column vector for A. We're asked to find the coordinates of the point A in terms of lambda. So what we've got is the point itself, A, is going to be lambda and 2 lambda minus 1. All right.